system of linear equation in several variable. We will focus more on system of linear equation in 3 variable in this lesson. And before we solve system of 3 variable, let's go over some operation that we can use to solve the system of linear equation. You can add a non-zero multiple of one equation to another. This means you can multiply one equation with a number for certain, say 3, and then add it to the one of the other equation that is available. Or you can also multiply an equation by a non-zero constant. You can interchange the position of two equations. There are 3 types of solution in a linear system. You can have exactly one solution, you can have no solution, or you can have infinitely many solutions. You can solve by either using substitution or elimination method. I'll go ahead and try to solve this first example using substitution. From equation 1, I will solve for x. I solve for x in equation 1. I get x equal negative 6 plus y plus 2z. I then will substitute this result into equation 2 and 3. So equation 2 now become and equation 3 now become and we will simplify this. And I'll go ahead and divide this equation by 3 because I can. By negative 3. So essentially I multiply everything by negative 1 over 3. So now what left over is the equation. Let's mark the star and 2 star. Let's put them next to each other. Note that when you do substitution, the resulting system is a system of 2 equations with 2 unknown, and we have the 2 same unknown. So the first equation have y and z, the second equation have y and z. I'll continue solving this using substitution. From the 2 star equation, I will solve for y. Y then equal to negative 4 minus 3z. I will sub this result into equation star. And the star now become So now that you get z equal 3, you can use this equation here to solve for y. So y is equal to negative 4 minus 3 times z. Now that we have z and y, we substitute into this equation here to solve for x. So now we have the solution to the system is the triple order pair, negative 11, negative 11, and 3. Take a look at the second equation. Let's say we're trying to solve this using elimination. Start with equation 1, 2, and 3. Let's say I want to eliminate an x. Okay, if I want to eliminate an x, let's say take a look at the equation 1 and 2 together. If I want to eliminate an x, I would like the x in equation 1 being negative 2. So I go ahead and multiply the first equation by negative 2. So then negative 2x plus 2y minus 10z equal 4. So I multiply the first equation here by negative 2. And let's just put the equation 2 and 3 next to each other. Let's put them all in. Plus y plus 4z equal to 2x plus 4y minus 2z equal 8. And so let's mark this equation 1, 2, and 3. I can go ahead and add equation 1 and 2. So equation 1 plus equation 2, the result, let's make it star. So when doing that, I get 0x plus 3y minus 6z equals 6. I can add equation 1 and equation 3 and get the 2-star equation. So that is 0 6y minus 12z equal 12. Okay. So I'll go ahead and simplify the first equation, this by 3. Y minus 2z equal 2. And simplify the second equation by 6. So y minus 2z equal 2. Okay. Now let's go ahead. Now if you're looking at this, you see this 2 equation is the same, right? This 2 equation is the same. So if you take star and subtract it by 2 star, you will get 0 equal to 0. This then implies the system have infinitely many solutions because this is a true statement. Let's take a look at the third problem. Again, I'll go ahead and solve this using elimination. This time I'll try to eliminate y. So take equation 2 and I will add with negative of equation 1. Okay. So if I do that, let's put out the 2 equations so that we can see clearly. So here's equation 2, that is 2x plus 2y minus z equal negative 6. Negative of equation 1 will get you negative x minus 2y plus 2z equal negative 1. And so if we perform that operation as we said, we will get x plus z equal negative 7. And since I already eliminated y, I need to stay with it. Yeah. So I will take equation 2. I multiply equation 2 by negative 2. And we'll add it with equation 3. So negative of equation 2 is negative 4x minus 4y plus 2z equal negative 12. 3x plus 4y minus 3z equal 5. Performing the operation on it, we get negative x minus z equal to negative 7. Okay, this means x plus z is equal to 7. So mark this equation star and 2 star. Let's put them back together. X plus z equal negative 7. X plus z equals 7. So let's go ahead and eliminate an x by taking the equation star and subtracting it with equation 2 star. Then I get 0 equal negative 14. So this is a false statement. This means the equation have no solution. So the system of equation have no solution.